You know that feeling when a web page just pops up instantly? Or when a video starts streaming without a single hiccup? We totally take that for granted. But it's not magic. It's actually an invisible network working behind the scenes. And today, we're going to pull back the curtain on the secret that makes the entire modern internet so fast. So think about this for a second. How can a video file that's stored on a server, let's say in the US, start playing instantly on your phone in Nigeria or India? I mean, the data literally has to cross oceans and continents in the blink of an eye. It sounds pretty much impossible, right? But it happens millions of times every single day. So what's going on here? Well, it turns out the biggest enemy of a fast internet isn't your Wi-Fi, it's physics. It's just plain old distance. The further data has to travel from a website server all the way to your screen, the slower your experience is going to be. This physical distance is the internet's ultimate speed bump.
Okay, let's make this super clear with an example. Imagine a website, and its main server, its home base, you could say, is located in New York City. Now, if you're browsing from Manhattan, sure, the pages are going to load up really fast. But what happens when the user is on a totally different continent?
Well, if a user in Nigeria wants to see that website, their request has to travel over 8,000 kilometers just to get to that New York server. And then all the website's data, the images, the text, everything has to make that exact same 8,000 kilometer journey all the way back. That massive round trip is what causes all the delay. So what does that 8,000 kilometer journey actually feel like? Well, it translates into a 4 to 6 second load time. And in internet terms, that is an eternity. Let's be honest, most of us would have already clicked away before the page even finished loading. Distance, it turns out, just creates a terrible user experience. There has to be a better way, right? Well, of course there is. And the solution is a really elegant piece of internet infrastructure called a CDN. That stands for Content Delivery Network. And it's the technology that was specifically designed to defeat the problem of distance. So what exactly is a content delivery network? You can think of it as a globally distributed team of servers. Instead of relying on just one single origin server, a CDN smartly places copies of website content in data centers all around the world, getting them physically closer to you and me. You've probably heard of the biggest names in this space, companies like Akamai, Cloudflare, and Amazon's CloudFront. Honestly, the best analogy for a CDN is a global fast food chain. You don't drive all the way to the corporate headquarters in another state just to get a burger, right? No, you go to the local branch that's just down the street. A CDN does the exact same thing, but for data. It creates these little local branches of a website all over the globe. Okay, so the concept makes sense, but how does a CDN actually work in practice? How does it pull this off? Well, it all boils down to a surprisingly simple three-step process. First, the CDN makes copies of a website's files. This is a process called caching. Then, it takes those cached files and distributes them to its global network of edge servers. Those are the local branches we were just talking about. And finally, when you go to visit the site, the CDN automatically figures out where you are and delivers the content from the edge server that's physically closest to you. It's simple, but it's absolute genius. Now, the most obvious benefit here is, of course, a massive, massive boost in speed. But the advantages of using a CDN go way beyond just making pages load faster. That's really just the beginning. Let's go back to our New York to Nigeria example for a second. The difference a CDN makes is just staggering. That painful load time of 4 to 6 seconds, it drops to less than 1 second. That is the incredible power of getting your data from a local server in a city nearby instead of from halfway across the world. But like I said, the benefits go way beyond just speed. A CDN also protects the main server from getting overwhelmed with traffic, which prevents crashes. If one CDN server happens to fail, your traffic is automatically rerouted to the next closest one, which means everything is way more reliable. It also adds a crucial layer of security, and for all of us who stream videos, it's the ultimate weapon against that dreaded buffering wheel. And here's the thing. This isn't just some obscure technology that's only for giant corporations. You interact with CDNs constantly, probably dozens of times a day, without ever even realizing it. Think about it. Every time you watch a YouTube video, binge a show on Netflix, scroll through Instagram, or shop on Amazon, yep, you're using a CDN. Even when your phone updates its apps, a CDN is delivering those files to you. This invisible network is truly the backbone that makes our modern, media-heavy internet possible. So, what's the bottom line here? What's the main takeaway? A CDN isn't just a feature or an add-on. It is a fundamental, absolutely non-negotiable part of the internet as we know it today.
I mean, just look at the difference across every key metric. Speed, reliability, security, video streaming. It's just night and day. A world without CDNs would be a much slower, way less reliable, and honestly, a far more frustrating place to be online. It's a complete transformation of the entire user experience.
And this is why, for any website, app, or streaming service that has users in different countries, a CDN isn't a luxury. It is an absolute necessity. It is the only way to guarantee a fast, reliable, and secure experience for every single user, no matter where they are in the world.
So, the next time you instantly stream a movie or you're on a crystal clear video chat with someone across the planet, you'll know the secret. It's that vast, invisible network of a CDN doing all the heavy lifting. Which kind of leaves you with one final question, doesn't it? What other invisible technologies are hiding in plain sight, quietly powering our digital lives every day?